Hey guys, we're back and we're going to be talking about alcohols, um, as in chemicals that contain another special group, and this group is an OH. Before I get anywhere with this, I'm going to tell you in no uncertain terms, just because it's got an OH, these are not bases. Bases either release an OH ion into water or they cause water to turn into an OH ion. Alcohols do not do this. Why is that? The OH group is stuck on a carbon with a very strong covalent bond, so it's not ionic. So if you see one of these molecules, know that they are not a base. Actually, alcohols are very, very slightly acidic, but we don't really talk about that. Shh, don't tell anybody. So, let's talk about alcohols. The OH group is not called a hydroxide. It's instead going to pick up the same ending that all of our branches get. So instead of hydroxide, it's going to get the suffix or the ending word "ill." So this becomes what's called a hydroxyl group. So that's some facts about alcohols. Uh, Alcohols that have a short number of carbons, between one carbon to around 4 to 5 carbons. They dissolve in water really nicely. And I can even do a subscript here. I should probably capitalize the H though, and the O. Boom. Well, that did not work. Let's fix that. Boom. There we go. Beautiful. So carbon, if you have a 1 carbon alcohol all the way up to around a 4 or a 5, they dissolve in water. Once they're longer than that, they're not very soluble in water. So let's take a look at some of our kind of basic alcohols. We'll start out with the most simple one, and that's simply just a single carbon atom with the hydroxyl group attached, and then the rest of the bonding spaces we put hydrogens. So we're seeing a pattern of these. It's always going to be a carbon with a whole bunch of hydrogens and then something, I usually just say something interesting. Something that's not just a hydrogen, something else stuck on there. So obviously there's our main chain, as silly as it is to call it that. Here's our hydroxyl group. So we know that if this was a hydrocarbon that was just H's around here, it would be called methane. But the nice thing about all of these chemicals, they tell you, they give you a hint about what to call them. Remember, alkenes ended in "ene" and alkynes ended in "ine", Y-N-E. Well, same idea here. Alcohols end in the sound "all". So all we have to do is cross out that E and replace it with the word or ending "all". So this guy, this molecule, is methanol. Quite simple. What if we graduate to 2 carbons? I'm just going to throw the OH here. Doesn't really matter. It doesn't have to be sticking out the right-hand side of the molecule. As a matter of fact, these molecules actually twist around. They've got mobility. The atoms can kind of scoot around wherever they need to be. As long as they're attached to the carbon, these guys can move around. So we've got 2 carbons now. Oops, did not want to do that because it makes the pen too thick. Okay, there we go. There's our main chain. So 2 carbon main chain would be called ethane, but since we have the OH there, it becomes ethanol. This is the alcohol that's in wine and spirits and things like that. Or rather, I should say it's the main alcohol. There is some of this guy in here, this methanol as well, and that is dangerous stuff. This is actually one of the reasons why people who make moonshine, for example, in like West Virginia and Kentucky and like the Appalachians, the American southwest, south central west part of, or sorry, east part of the country, when you consume the high-powered ethanol that these people make, if they're doing it wrong, they may not have removed all the methanol from it, and that can cause neurological problems beyond just the consumption of ethanol alone, because this stuff's not great already, but this stuff's worse. This can cause blindness. So let's move on to 3 carbons. And the reason why I like to go to 3 carbons or sometimes more is because that's when the numbering starts to matter. So I'm going to put the OH up top there, and for the rest of the spots I'm just simply going to put hydrogens, kind of what we're used to. Okay, so it's a 3 carbon main chain. So that would be a propane. But here's the kicker. This OH group, it could have gone here. The carbon that it's attached to in this case matters. So I need to say what carbon it's attached to. So it is attached to carbon 1, which means that this molecule is called, oops, I should make that like an actual one, propan 1-ol. You might be wondering, hey Lorenz, why didn't you do ethan 1-ol for this guy? Well, the simple matter is, if I were to move this OH group over to the other carbon, that would become carbon number 1. Because we prioritize getting the OH to the lowest number that you could get it. So propan 1-ol, can we make propan 2-ol? You bet we can. So here I'm going to put, instead of putting the OH, the hydroxyl group, on the ending carbon, the terminal carbon, we're going to put it on the secondary carbon, the one in the middle. So it's still going to be propan-ol. It's still 3 carbons in the main chain. So propan. But this time the hydroxyl group is on carbon number 2. It's on the middle carbon. And this guy is actually something that's pretty famous, I guess you could say, these days. This is an alcohol, the regular people name, because you're not going to go to a pharmacist and be like, I need some propan 2-ol. Your pharmacist would know what that is because they took organic chemistry in high school and they for sure took it in university. But they're not going to, they might look at you funny and be like, wow, is this high school student just trying to flex on me. All they're trying to buy is, oops, all they're trying to buy is rubbing alcohol. Interestingly, as far as this alcohol, all of these alcohols have disinfecting and germ killing properties. Just a quick think back to the unit on the immune system, Unit A. Uh, we talked about viruses, and we said that viruses are a little bit of genetic material. Sometimes they're DNA, and sometimes they're the secondary genetic material called RNA. Uh, SARS-CoV-2 is actually a single piece of RNA. But the thing that viruses have in common is they have a coating. The coating determines how the virus, gets into cells, etc. And the composition of the little coating, it's like a little shell. Think about it as like the worst Kinder Surprise egg in the world. So instead of it being, decent chocolate, or I think it's kind of weird chocolate, but I like it. Weird chocolate on the outside and a toy on the inside. The outside of a virus is usually proteins and sometimes maybe a little bit of lipoprotein, so lipid, fat-based or fat-appended proteins. And then the inside is, like we said, a genetic material. And these chemicals, methanol, ethanol, propanols of various flavors, propan 1-ol, propan 2-ol, they disrupt the protein on the outside of the virus. These mess up the shape of the protein that's coating the virus. When the protein shapes get messed up, they can't do their job because the function of a protein depends on its shape. So, you have a fork and you can use it to stab food. If all of the tines of the fork were bent in different directions, it wouldn't be able to get food as well. So, most everything depends on its shape. If you have a bottle that you have like a water bottle, the only reason it contains water is because of its shape. If you melted that plastic bottle down into a little puck, a little nugget of plastic, it's not going to carry water anymore, is it? So these molecules of alcohols, they screw up, they deform, they denature, they alter the shape of the proteins, and then they can't be functional anymore, and they cannot infect you. So that's quite fascinating. We don't use methanol because methanol, if you don't want to use that as hand sanitizer because methanol gets through your skin very easily, and like we said, it's toxic to your nervous system in a very, very big way. So we don't want to use that. Ethanol, I know a lot of distilleries actually in the city and across the province and across the country and even in the States. They have switched their capacity. This is fascinating too. They used to make, obviously, beverages, spirits for people to consume, but some of them have diverted some of their capacity and they're making ethanol. Because, that's what spirits are. They're ethanol with water and some flavorings. And so what some companies have done is they're like, all right, we're just going to make ethanol and we're going to add a gelling chemical to it, and that gel chemical is going to make it so that it can be used as hand sanitizer. Wonderful. Works really well. Yeah, lots of distilleries around the city have started making hand sanitizer and giving it away for free, which is awesome. Like, hats off to those folks. As far as isopropanol, aka rubbing alcohol, amazingly enough, you might think, and this is, I wouldn't blame you, that the higher the percent, the better. So yeah, you can get 99%, which means that 99% of the container contains this, and 1% of it is H2O, it's water. amazingly, that is not the most effective percentage. The most effective percentage is actually 70% isopropanol. And it's for some very complicated reasons, but I'll give you the long and the short of it. This is the amount where the water can dissolve and carry away, like move around, the broken pieces of protein. So the alcohol breaks the proteins up, and then the 30% water inside of this will move those protein pieces away. So it works actually better. And also 70% stays on a surface for longer. In other words, it evaporates away much slower. So let's do one more example here. I'm going to get a blank page. We'll do one that has a branch. So I'm going to put my OH right here. And you know what? Let's put a CH3. That's a C with 3 carbons. And I'll put another CH3 here. I'll put little tickies for all the rest of my carbons. So business as usual, right? We want to get the main chain. Now, some of you might have a feeling that we need to include the OH in our formula, or sorry, in our main chain. Actually, I'm going to tweak this just a bit. I'm going to add another carbon onto this one. And the reason why is to mess us up. So some people might think, okay, well, this is the longest chain. There's 5 carbons there. Go me, I am so smart. And it doesn't work. We got to include the hydroxyl group. So we're going to include that hydroxyl group. I think 4 carbons is the best we can do. 1, 2, 3, 4. Yeah. That's the best we can do. So now we have to kind of explain what's going on in the molecule. So we have an ethyl group here, we have a methyl group here, and we have our OH, our hydroxyl group here. So since this is 4 carbons, it gets the word but, and it's going to be butan. And now you might be wondering, okay, how do I number this? When there's an OH in the mix, you want to prioritize getting the number of the OH as low as possible. So we're not going to number this way. We don't number left to right in this case, because then we'd have a butan for all. That doesn't make sense. The best case that we could do is to number the other way. So this is going to be butan 1 all. Now we just have to explain what's going on with these. And remember, we've committed to numbering the way that we have. So we can't change it now and be like, well, now I'm going to count the other way. You're not allowed to. So we have an ethyl group on carbon 2, and we have a methyl group on carbon 2. So we have to put these in alphabetical. So I'm going to say 2-ethyl, 2-methyl. So 2-ethyl, 2-methylbutan, 1 all. Fantastic. Let's just do one more example just to make sure that we understand how the numbering works. I'm going to get back to a pent here. And let's throw the hydroxyl group on here. And let's see. I can't do that. One sec. I'm going to erase that. Let's do another carbon there. And let's do another carbon there, and we'll put our tickies on there. Tick, 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 tick. There we go. So business as usual, we're looking for the longest chain that contains our special bit, just like how we look for the longest chain that contained the double or triple bond. We always look for the special thing. And so I'm looking at 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or straight across. I'm just going to be interesting and we'll go up. It doesn't really matter. Remember, these are going to be interchangeable. 1, 2, 3. We got 3 methyl groups, and then we have our hydroxyl group, our alcohol. So this is 1, 2, 3, 4, 5. It's a pent. Ooh, I'm going to have to move this over. So pentan, it's on carbon number 3. Either way I slice it. So this is pentan 3 all. And I'm just going to move this down now because I know I'm not going to have any space. And now let's continue on with our branches. So I'll do the branches in this case in blue. It doesn't really matter what color I'm using. So let's see. We have, if I count this way, left to right, or 1, 2, 3, 4, 5. If I count this way, I'm going to have a 2, 4, 4 trimethyl, because there's a methyl on carbon 2, 2 methyls on carbon 4. Can we do better? Oh yeah, for sure. If we go 1, 2, 3, 4, 5, I've got 2, 2, 4 trimethyl. If you just compare these, put my little commas in there, 2 plus 2 plus 4 is 8, 2 plus 4 plus 4 is 10. We want to get the lowest number, so 2, 2, 4 is correct. So we're going to have 2, 2, 4 dash trimethyl. And then we'll scoot that over so it's part of the word. And there we go. So 2,2,4 trimethyl pentan 3 all. And yeah, they do get awkward and long. Are you going to see something this difficult? Probably not. So I'll see you next time, which is going to be right shortly, where we are going to be talking about carboxylic acids.